Welcome to A-Level and AP Physics. In today's lesson, we will discuss past paper questions on mechanics from October-November 2022, Paper 2, Variant 1. In this lesson, as always, we will discuss these questions in detail so you can improve your conceptual understanding of this topic and also you can have better understanding of these questions. Let's study together. Let's improve together. In today's lesson, we are talking about October-November 2022, Paper 2, Variant 1. Total time for this exam is 1 hour and 15 minutes and total mark for this paper is 60. If you want to get A star in A-level physics, you need to get in paper 1 about 35 out of 40 marks. And in paper 2, you need to get about 50 out of 60. And in paper 3, you need to get about 32 out of 40 marks. And in paper 4, you need to get 80 out of 100. And in paper 5, you need about 25 out of 30 marks. If you can get these marks in these papers, it means 100% you will get A star. On second page of exam paper, data is given to you, means values of some constants are given to you. If you need value of any constant for some calculations in your exam, you can come to the second page of exam paper and you can find values of constants. And also you need to understand at AS level, you have to use G is equal to 9.81 meters per second. You cannot use G is equal to 10 meters per second. You will lose marks if you use G is equal to 10 meters per second. So at AS level, you have to use G is equal to 9.81. You have to be very clear about this point. On second page of your exam paper, you can also find some important formulae, but these are not all the formulae you need for AS physics. So it's better if you can remember all the formulae, and also it's very important if you understand how to derive formulae, because it's very important to understand how to derive formula, because when you derive a formula, you understand the basic physics behind that. So always try to derive formula. But for exam, you need to remember all the formulae for AS physics, but some important formulae you can find on this page. If you have forgotten any formula, you can come to this page and you can double check so you will not make mistakes in your exam. For question number 1, part A, we need to draw a line between each term on the left and a correct example on the right. And this question is simply about System International, means simply about SI. In System International, we have base units and quantities, means base quantities and units. Also, we have derived quantities and units, derived. So we can also write on here, we have base quantities and also we have base units. Then also we have derived quantities and also the units, derived quantities and units. But we need to be very clear about this one. We have only 7 base quantities and base units, but we have much more than 7 derived quantities and the units. So it's very important. We have greater than 7 derived quantities and units, mean much more than 7. So if this point is clear to you, now simply we can answer this question. First is asking you about base quantity. Base quantity. The base quantity is electric current. So we can simply say the base quantity is electric current, because this is the base quantity. In the 7 base quantities, electric current is one of them. So this is base quantity. Next one is asking us about base unit. kg is a base unit. So this one is base unit. Derived quantity. Force is a derived quantity. Derived unit. Coulomb is a derived unit, because coulomb we can derive from ampere. So this is derived unit. Coulomb is derived unit. So these things you need to understand. So SI system consists of 7 SI base quantities and 7 SI base units. And there are much more than 7 derived quantities and the units. I hope this point is clear to you. For the second part, it is given to us a set of experimental measurements is described as precise and not accurate. We need to state what is meant by precise and what is meant by not not accurate. First of all, let's try to understand what is meaning of precision. Precise means that readings are close to each other. So in a simple language, we can simply say precise means that readings are close to each other. Readings are close to each other. So this is meaning of precise. Readings are close to each other. Or you can also say, in this case, readings have small range. If the range of the readings is small, it means readings are precise. You can also understand this one with one simple example. Imagine that we have readings 15.5 centimeters. We have 15.2 centimeters. We have 15.4 centimeters, and we have 15.0 centimeters, or we have 15.3 centimeters. So in this case, these readings are very close to each other. Imagine that the actual value is 17. So we can imagine that actual value is 17 centimeters. But this is the data. These are the measurements we have taken with the help of instrument. Now, if you look at these given values, these values are close to each other, but they are not close to the actual value. So this data, we will say this data is precise, but this data is not accurate. So this one is not accurate. So this is not accurate. Later we will discuss accuracy in detail. So this data is precise because readings are close to each other and the range is small. So this data is precise. So let me show you the answer, how you can write on the answer. So you can simply say the measurements have a small range. So this is how you can define precision. Or you can say measurements are precise. Now let's try to understand what is meant by not accurate. When data is accurate if the mean value is close to actual value. Then we can say data is accurate. Mean value is close to actual value. So we can say data is accurate. So this is how you can define accurate. Your data is accurate if the mean value of your data is close to the actual value. But in this case, if we take the mean value that is not close to 17 centimeters, so it means this data is not accurate. So this is the point you need to understand. So data can be precise, but still it cannot be accurate. For the second part, this is how you can write down your answer. Simply you can say average of the measurements not close to the true value, or you can say mean of the measurements is not close to the actual value. I hope this point is clear to you. What is meant by precision and what is meant by accuracy. So when we talk about accuracy, we calculate mean value of the data and we compare that one with true value. And when we talk about the precision, so if the measurements are close to each other, they have the small range, we can say data is precise. You can also understand like this. Imagine that these fingers, these are the measurements. If these measurements are close to each other like this, so it means this data is precise. If these measurements are away from each other, so it means this data is not precise. For part C, formula for the force is given to us and percentage uncertainties for force, for mass and radius are given to us. And we need to calculate the percentage uncertainty in V for part 1. So very straightforward question. So the best way to answer this problem is, first of all, you can rearrange this equation. So if we rearrange this one, we can simply write down V square. This one will be equal to FR divided by M. So we have to make V the subject because we need to calculate the percentage uncertainty in V. So now simply we can write down V in this case will be equal to FR divided by M, and the power of this one is 1 by 2. We need to calculate the percentage uncertainty in V. So the percentage uncertainty in V, this one will be equal to 1 by 2 times percentage uncertainty in F plus percentage uncertainty in R plus percentage uncertainty in F. So this is the point we need to understand, because in this case these quantities are multiplied and divided, so we need to add percentage uncertainty, and this also has a power, so we have to multiply by power. Power is 1 by 2, so we have to multiply by 1 by 2. Now simply we need to plug in values. Percentage uncertainty in F is given to us, that is equal to 3%, so we can say this is 3%. And percentage uncertainty in R is given, that is 5%. So we can write down this is 5%, and percentage uncertainty in mass is given, that is 4%. Now simply if we add all of them together, we will get this is 1 by 2, and here we will get this is 12%. Now we divide by 2, so we will get 6%. So this is our final answer. So this is the percentage uncertainty in V, and this is how you need to approach. For the second part, it is given to us the value of V is 15.0 meters per second, and we need to calculate the absolute uncertainty in V. But we have already calculated percentage uncertainty in V, and percentage uncertainty in V, this is equal to 6%. So we can convert this one into fractional uncertainty. So we can say delta V by V, this one will be equal to 6 divided by 100, because this is 6%. Now question is asking us to calculate delta V. So delta V simply will be equal to 6 divided by 100 multiplied by V, and V in this case is equal to 15.0. So if we solve this one, our final answer will be equal to 0.9 meters per second. If we use only one SF, up to one SF, our answer will be 0.9. And absolute uncertainty at AS level, you have to write down up to one SF only. So our final answer for this question is 0.9. One SF only, very important. So at AS level, you have to use only one SF for absolute uncertainty. For the second question, it is given to us a steel ball is projected horizontally from the top of a table as shown in figure 2.1, and its horizontal velocity is given to us, and also horizontal displacement is given. For this question, we can also assume A resistance is negligible. If A resistance is negligible, it simply means that there is no force along horizontal, so the acceleration along horizontal will be equal to 0. So simply we can say in this case AX, this is equal to 0. So simply we can say horizontal displacement X, this is equal to UX times time plus 1/2 A t square. But in this case AX is equal to 0, so it simply means that horizontal displacement is simply equal to X times UXT. We need to calculate T for this question. So T is equal to X horizontal displacement divided by UX, means the initial horizontal velocity. Value of X is given to us, but X is given in centimeters, so we have to convert this one into meters. So we have to divide this one by 100 divided by velocity is given in meters per second, so simply you can use 4.9 meters per second. And if we solve this one, our final answer in this case will be equal to 0.37 seconds. So this one is the final answer. Our final answer has 2 SF because the raw data, it has 2 SF. For the second part, we need to calculate the vertical component of the velocity of the ball as it hits the ground. If you look at this point, the horizontal component of the velocity, it will be equal to the initial horizontal component of the velocity, and that is equal to 4.9 meters per second. Then question is asking us to calculate vertical component of the velocity when the ball hits the ground. I mean, this component of the velocity we need to find out. We need to find out vertical component of the velocity, so we need to consider only vertical motion. So we can say V sub V, vertical motion. So we need to look at vertical motion only. So the best way to answer this problem, you can simply write down vertical motion. If you look at vertical motion, initial vertical velocity is 0. So we can say UV, U sub V is equal to 0. But in this case, we have already calculated time taken from this point to the ground, or you can say from this point to this point, or you can say from this point to this point. Horizontal or vertical time taken is the same. So time taken is equal to 0.37 seconds. Now question is asking us to calculate value of V, but in this case acceleration A, this is equal to G, and value of G is equal to 9.81 meters per second per second. We need to calculate value of V. So V we need to calculate. calculate. Means the final vertical velocity we need to calculate. So simply we can say V sub V, in this case will be equal to U sub V plus 80. And in this case we will take downwards as positive, so we will take downwards as positive. So if you take down as positive, it means acceleration is positive. Now simply you need to plug in values. In this case U sub V is equal to 0 plus we have 9.81 times we have 0.37. So the final answer in this case is equal to 3.6 up to 2 SF, because the raw data, this has 2 SF, means the least number of SF in the raw data. This is 2 SF, so our final answer also should have 2 SF, or you can use one more. So this is the final answer. For the third part, we need to determine the magnitude and angle to the horizontal of the velocity of the ball as it hits the ground. But we have already calculated vertical component of the velocity, and we also have the horizontal component of the velocity. So simply we can rewrite again. So we have horizontal component of velocity, that is equal to 4.9 meters per second, and we have calculated vertical component of velocity, that one was equal to 3.6 meters per second. Now we need to calculate in this case final velocity. So you can in this case simply draw this arrow, and this is representing direction of final velocity. And this velocity has two components. We can take this component, we can place this one here. So this one is the triangle. Simply you can imagine this is the triangle. So we have horizontal component, we have vertical component, and the value of this one is 3.6 meters per second. And question is asking us to calculate this angle, and also the value of V. We can simply say this is V. So if we need to find V, so V in this case simply will be equal to 3.6 square plus, because this is right angle triangle, plus 4.9 square. And if we solve this one, we can find out value of velocity, and that will be equal to 6.1 meters per second. So the magnitude of the velocity is 6.1 meters per second up to 2 SF. We need to find out this angle. So the angle, simply we can say in this case tangent of theta. So we can say this angle is theta. This will be equal to vertical component divided by horizontal component. From here we can calculate value of angle. So this is theta. So we can take tan inverse of 3.6 divided by 4.9, and final answer will be equal to 36 degrees up to 27. So this is the value of angle with horizontal. For part B, it is given to us the ball is a uniform sphere of steel of diameter 0.016 meters, and the mass of the ball is given. We need to calculate density of the steel. So quite straightforward question. We need to calculate density, and we have the mass. So if we can calculate volume, so we can find the density. So in this case, mass is given, that is in SI base unit. So we can simply say 0.017 kgs divided by volume. And volume of the sphere is 4 by 3 pi r cube. And simply we need to plug in values now. So we can say this is 4 by 3 pi r cube, but the diameter is given to us, and this is also in SI base units. So simply we need to divide diameter by 2. 0.016 divided by 2, and we need to take cube of this one. Now if we solve this, our final answer in this case will be equal to 7,900 kgs per cubic meter up to 2 SF. So our answer is up to 2 SF, because the raw data we have, this has 2 SF, this one has 2 SF, this also has 2 SF. So our final answer also we need to use least number of SF in the given data. So our final answer is 7,900 kgs per cubic meter. For the second part, it is given to us all of the elastic tension energy in the spring is converted into kinetic energy of the ball. The speed of the ball as it leaves the spring is 4.9 meters per second, and we need to show that maximum elastic tension energy of the spring is equal to 0.20 joules. First of all, let's try to understand this one with the help of this figure. When the spring is fully compressed, at this point, its initial elastic tension energy, this has maximum value. So it has maximum value. and at this position ball is not moving, so the kinetic energy of the ball, this one is equal to 0. And when this spring is unstretched means the compression in the spring, this is equal to 0. At that point EPE will be equal to 0, so we can simply say EPE final, this is equal to 0. And kinetic energy of the ball at this point, this is maximum. So this is final kinetic energy and this one is maximum. And this question is simply about conservation of mechanical energy. So we can say in this case EPE, the change in EPE, this is equal to change in kinetic energy. And total change in energy in this case is equal to 0. And change in EPE, final EPE is equal to 0. So we can simply say the change in EPE is equal to EPE maximum. So we can say this is EPE maximum. So EPE maximum means the initial value of EPE. This is equal to final value of kinetic energy. And final value of kinetic energy is 1/2 mv squared. And these two quantities are same. So simply we can plug in values. Mass is equal to 0.017. This is mass of the ball. And speed of the ball is given to us. That is 4.9. We have to take square of this value. If we solve, our final answer will be equal to 0.20 joules up to 2s. And this is what we need to show, that maximum elastic tension energy is equal to this value. So this question has 2 marks. You will get the first mark if you have written this formula, and the second mark if you have got the right answer. For third part, we need to use figure 2.4 to determine the spring constant K of the spring. But we have force on y-axis and we have compression, means we have x on x-axis. We need to find out value of K. So simply K in this case will be equal to force divided by extension. So we can take any value of force. In this case, I'll be choosing this point. At this point, we have value of force that is equal to 6.4 newtons, and we have value of extension that is equal to 10 centimeters. So we need to multiply this one with 10 to minus 2 because we have to convert this one into SI base units. And now simply if we solve this one, our final answer will be equal to 64 newtons per meter. So this one is the final answer. For part 4, we need to use our answer from B theory and the value of energy given in B2 to determine the compression x0 of the spring. In part B2, it was given to us that EPE, elastic tension energy, is equal to 0.20 joules. In part B theory, we have calculated value of K that was equal to 64 newtons per meter. Now we need to calculate value of compression. So simply you can say in this case EPE is equal to 1/2 kx squared. And we need to find value of x. So if we rearrange this one, we can write down in this case x squared. This one will be equal to 2e divided by k. We need to find out value of x naught. So we have to take square root on both sides. So we can say 2e divided by k. And now we can plug in values. So we have value of e that is equal to 0.20, and this is divided by K that is equal to 64, and we need to take square root, means the power of this one is 1/2. If we solve this one, value of x will be equal to 0.079 meters. So this is our final answer up to SF. For part C, it is given to us the steel ball is replaced by a polystyrene ball of the same diameter but of much lower mass. The spring is given compression x0 and is then released. Air resistance on this ball is not negligible after it leaves the spring. We need to explain why this ball leaves the spring with a greater speed than that of the steel ball. So first thing we need to understand, in this case compression in the spring is the same. So we can say elastic potential energy is the same. So EPE is the same for these two balls, and EPE in this case will be equal to 1/2 mv squared. Mean the change in EPE, this is equal to change in KE. Simply we can say the loss in EPE, this is equal to gain in KE. And from here we can find out the speed. So V will be equal to 2 times EPE divided by m and root of this one. From here, you can simply see that if the mass is lower, it means speed will be greater. So the polystyrene ball will have greater speed because it has lower mass. So these two balls, they have the same EPE, and the second ball, it has lower mass. So the speed of second ball will be greater. So let me show you the answer. This is how you can write down the answer. In your answer, you can mention these points. They have the same elastic potential energy, and polystyrene ball, it has lower mass, so the speed of this ball is greater. For the second part, we need to explain why this ball takes a longer time to reach the ground than the steel ball. But in this case, it is given to us the steel ball has a greater mass. So we can say this one is steel ball. Let's say the mass of the steel ball is capital M, and the mass of polystyrene ball, let's say, is small m. So the initial force acting on steel ball, this is equal to its weight. So this is capital mg. And the initial force acting on this one is small mg, and this force is lower than the force on the steel ball. Now after a short period of time, if we draw the free body diagram, let's say the A resistance on these two balls is the same. So we will see A resistance in this case equal to this. Just imagine that. So this is the mg, and in this case the resultant force will be this big. So this one will be the resultant force. But if we draw free body diagram for this one after a short period of time, so we will say in this case this is the weight of the second ball, and A resistance, if we draw the equal length of arrow, so this one is A resistance. And in this case F net is almost equal to 0. So F net is almost equal to 0. But in this case we have F net because the weight is greater than A resistance. So this ball is still accelerating downward, but this one has reached terminal velocity. So simply net force on the second ball is smaller, so this will take longer time to reach the ground, and net force on steel ball is greater, so it will take shorter time to reach the ground. Or simply we can say the effect of A resistance on this one is more significant as compared with effect of A resistance on steel ball. So if we have understanding of these points, and then simply we can write down our answer. In answer, if you only mention about resultant force, you will get 1 mark because this question has only 1 mark. So we can say for the polystyrene ball, there is less resultant force, so it takes longer time to reach the ground. You can see here it's a beautiful way I have explained to you here. So let's try to understand this one in a bit proper way. If you want to draw a proper free body diagram. So let's say for the steel ball, after a certain period of time, we have A resistance acting on this. Let's say this is representing A resistance, and the force acting downwards, that one is the weight of this. So this is the weight of the steel ball. And also we can draw polystyrene ball here. So this is polystyrene ball, and A resistance on this one is also the same. So after a certain period of time, because they have the same size, the A resistance is the same. So we can draw a bit longer, 0.7. This is 0.7 centimeters. Now, if we draw in this case, the weight of this one is lower than the weight of the steel ball. So in this case, you see these two forces are almost balanced. So it means it has already reached terminal velocity. So this one will take longer time because the resultant force on polystyrene ball is smaller than resultant force on the steel ball. So steel ball is still accelerating, that this one has reached terminal velocity. So this one will take longer time.